Good evening. Welcome to the week 5 of the tutorial session of this course, Digital Signal Processing and its application. So today we'll solve question related to the week 5. We'll wait for a minute and then we'll start. So basically in today's lecture we will see question related more to the jet transform. So before that we'll see the concept of jet transform. So jet transform is the discrete time counterpart of the Laplace transform. What we study for continuous time domain, and the frequency domain analysis of discrete time system allow us to present like any signal xn as the sum of exponential of the form z to the power of n. So we'll see the equation. So let's consider discrete time signal xn. So its z transform is given as, like first of all it is denoted by x of capital X of z, and this is summation of xn z to the power minus n, and the value of n goes from minus infinite to plus infinite. So actually z is here the complex variable which is given as, also z is equal to r e to the power of j omega. So we can write the z transform pair as, the z transform of xn is given as x of z, and the inverse of x of z is, that is inverse z transform, that is x of n. So inverse of z transform is given as x of n. The equation is 1 by 2 pi j integration of xz z to the power of n minus 1 dz. But mostly, like we will see in this lecture, like to find the z transform only. And now, we will see the reason of convergence. Like Z transform is guaranteed to converge if like xn dot r to the power of minus n is absolutely summable. Okay, so here, So Z transform is like guaranteed to be converged when if xn multiplied with r to the power of minus n is absolutely summable. Okay, that is summation of x and r to the power of minus n. The mod of this whole quantity is less than infinite. So this condition shows that xz will be finite. So this condition implies that xz, the magnitude of xz will be less than infinite. Okay, and the region of convergence consists of those values for which like the mod of z is like we can write z as r e to the power of j omega. This is equal to r for which z transform converges. So there are various properties of z transform, but we'll see those and also we'll solve some of the problem. So the first question, so let's solve this question first. So because this this question uh, based on the ROC. So we'll solve this first. So let a given function nk is equal to k to the power of n u of n, where u of n is 1 for n is greater than minus 1 and 0 elsewhere. So u of n is 1 when n is greater than minus 1. So for 0, for 1, for 2, all value is 1 and after that it is. So now it's asking in the question, which of the following sequences have a DTFT? So the first one is Fn 1 minus 1.1. So this is k to the power of n. Our Fnk is k to the power of n u of n. So we'll substitute those values. So n is 1 only here. So this is minus 1.1 to the power of n un. So you can see simply here like this minus 1 to the power of n is given. Okay. So whenever the value of n increases, uh, like uh, whenever the n increases, this value will tend to infinite. Okay. For the first one. Now for the second one, like when n tends to infinite, this value tends to infinite. In the option B, that is minus 1.1 to the power of minus 1. So this we can write here. So now we will see whether this is summable or not. So we have to like when n tends to minus infinite, so this term become again infinite. Okay. Now option C is 0.9 to the power of minus n. So here when n tends to infinite or minus infinite also, this will converges. The sequence is absolutely summable. So option C is and converges. Correct. I will check for option D. So again is 1.1 to the power of minus n into 1.01 to the power of n plus I plus 1 to the power of minus n. Okay? Or few of them. So here this will also explode and this is not a correct option. So option 1 is the correct answer for this question. So again we'll solve the next question now. Actually this is common in this slide also. So we'll delete it from one place. Now it's correct. The next question is let there be two signals x1n and x2n having Z transform like x1z is given as r naught by r naught minus z. Here mod of z is less than r naught. And the region of convergence is given as mod of z is less than r naught. Now x2z is equal to minus r naught divided by r naught minus 2z. And region of convergence is mod of z is greater than r naught by 2. So determine the signal x3n that is equal to x1n plus x2n and the ROC of its we have to find ROC of its Z transform. So we can write x1z is equal to 1 plus like the sum it is given r naught by r naught minus z. So this is actually the sum of the uh, series 1 plus z by r naught plus z by r naught square plus z by r naught to the power of 3 so on. So this is we can write as sum r naught to the power of n u of minus n z of minus n. Okay, this is r naught by z to the power of n series. So what we got our x1n is equal to r naught to the power of n u of minus n. because this is our x1 and then only when you multiply with z to the power of minus n, we get our x1 z. That is the z trans. Now, similarly, we can find our x2n can be written as r naught by 2 to the power of n u of n minus 1. Now, adding the two option, we get our like the value of like region of convergence r naught by 2. So ROC will converge within this region. Okay. So basically the ROC is R1 intersection with R2. So which option is correct? So here you can see X3N is X1N plus X2N. So we can simply write, we will take R naught to the power of N common. So you will get U of minus N plus U of N minus 1 and ROC is between R naught by 2 to R naught. So option A is the correct answer for this question. So like there are some properties of region of convergence that we will see now for the ease of understanding. So the ROC of the Z transform X of Z consists of a ring in the Z plane centered about the origin. So like properties number one. So in the Z plane, it consists of a ring. Now, like let's suppose if this is our ROC, this area, so it will consider all the rings between this area. Okay. So here I will write once again in the language form. The first property is ROC of XZ consists of a ring in the Z plane centered about origin. Now, the second property is ROC does not contain any pole. Now the third is, if like it is a finite duration signal, then ROC will be entire Z plane except Z is equal to 0 and yeah, or Z is equal to infinite. Okay, like it does not contain the like Z is equal to 0 or Z is equal to infinite ring. Like it does not contain the origin and the infinite uh, ring, like the radius having the infinite. Now, when xn is left-sided sequence, then the ROC will be less than R naught, right? For xn is left-handed or left-sided sequence, and if mod of z is equal to R naught is in ROC, then the ROC will also be in ROC. Okay. Next is, if xn is right-sided sequence, and if mod z is equal to R naught in ROC, then all the rings having the radius greater than R naught will also be in the ROC. So these all are some of the important properties. There are many more. So we'll look after solving the example. So now let's take one example. The ROC of Z transform of the discrete time sequence xn is equal to 1 by 3 to the power of n u of n minus 1 by 2 to the power of n u of minus n minus 1 is. So we have to find the ROC of this sequence. So here xn is given as 1 by 3 to the power of n u of n minus half to the power of n u of minus n minus 1. So 1 by 3 to the power of n u of n. So this is something like this sequence. Okay. So this is right sided signal. So ROC will be greater than 1 by 3. Okay. The second one, 1 by 2 to the power of n u of minus n minus 1. This is left sided sequence. Okay. If minus is there, then it will be in this form. So The ROC is less than 1 by 2. So from this first and second, we can see that ROC of a function will be greater than 1 by 3 and less than 1 by 2. So this was just a simple question. So now we'll move on to the next question. The jet transform of signal given by xz is equal to this for region of convergence is less that mod of z less than 1. What is x of n? Here un stands for unit step and del n means impulse signal. So x of z is given as 4 minus 2z minus 4z squared plus 2 of z cubed divided by 1 minus z squared. So this we can write as 4 minus 4z squared divided by 1 minus z squared plus 2z cubed minus 2z. We have just divided into the two parts. So now when you take 4 common, it will become 4 by like 4. It will become only 4. So this we can write as 4 minus 2 of z. So now the inverse z transform, like this is our x of z, and x of n will be the inverse z transform of 4 is 4 of del n minus 2 of del of n plus 1. Okay, so option number A is the correct answer for this question. So now we will solve the next question. As it, which of the following signal contains 0 in ROC of its Z transform? So this is a multiple select question. So what is the case here? Contains 0 in ROC. So for 0 to be in ROC, the Z transform should exist at Z is equal to 0. So now coming to option number A, that is del of n plus 2 del of n minus 1 plus del of n plus 1. So the Z transform will be 1 plus 2 by Z plus Z. Option B, u of n plus 1. So the Z transform of this is Z plus 1 by Z plus 1 by Z square plus so on. Option C is cos of 0.75 n u of minus 1 minus n. So Z transform will be cos of 0.75 Z plus cos of 0.75 squared Z squared plus 1. Now option D is sine of 0.7 pi n u of minus n plus del of n plus 3. So for del of n of 3, that will become z cube plus 1 plus z sine of 0.75 plus z square sine of 0.7 pi square and so on. So in option C and D, there is no singularity at z is equal to 0. Like, so option C and option D will have, like, see here, if you put z is equal to 0, so this term will go as infinite. It won't exist. Here also z is equal to 0. It won't exist. So option C and option D does not have anything like discontinuity or like it exists for z is equal to 0. So the correct answer is option C and option D. So now one of the properties of Z transform is like Z transform of n of x of n is equal to minus Z d of xz by d of z. Compute inverse Z transform of x of z. So, so this is our x of z and we have to compute the inverse Z transform of this. So we can write z by 1 minus z square is equal to minus z d by dz of 1 by 1 minus 1 by z. So when we write this, so these both are equivalent. So now our the z transform that x of z is equal to 1 by 1 minus 1 by z. So, so xn is equal to un, then xz is equal to 1 by 1 minus 1 by z. But here it will be n into x of n. So this is n into u of n is the correct answer for this question. So how many different signal using given Z transform? Like the Z transform of Xn is this. How many different region of convergence could correspond to X of Z? So Z naught is equal to 1 by 2Z. Z1 is equal to minus 1 by 2Z. From here, Z2 is equal to 1 by 4 and Z3 is equal to minus 3 by 2. So there will be four region of convergence. This is a simple question. Now what will be the Z transform of x of n is equal to half to the power of mod of n. So we know that x of n is equal to a to the power of mod n can be written as, okay, for the negative side it can be written as a to the power of minus n for negative value of n. For positive value of n it will be written as a to the power of n. So now let's evaluate the Z transform of, like, let's suppose this is our x1 n and this is our x2 n. So Z transform of x1 n is equal to z by z minus a, and ROC will be mod of z is greater than mod of a. Now Z transform of x2 of n, that is given as a to the power of minus n u of minus n minus 1. So for this it will become summation z to the power of minus n. So this can be written as summation of az to the power of n. So this will become minus 1 where to become n is equal to 1 to infinite. Okay, because this is for only negative value of n. So now we have taken az to the power of n. So like when it was minus n, then value was negative. So now, so this will become positive. Okay, negative of negative will become positive. So we can write it as a to the power of n is equal to 1. Now when you substitute n is equal to 0, it will become like minus 1. The value will be minus 1 plus summation of, because now we are doing from n equal to 0 to infinite. So just we are adding 1 and subtracting minus 1. So this will become az by 1 minus az, and ROC will be mod of z less than 1 by a. So z transform of x of n is equal to z transform of x1 of n plus z transform of x2 of n. This is equal to z by z minus a plus az by 1 minus az. And ROC will be mod of a is less than mod of z, and this is less than 1 by mod of a. Okay. So therefore, for a is equal to half, what value we will get? We will get z by z minus a, 1 by 2 minus z by 1, like a of z, z by z minus a. Now a of z, that is 1 by 2 of z divided by 1 minus 1 by 2 of z. Okay. So this will be the answer, and ROC will be mod of z is greater than 1 by 2 and less than 2. So option C is the correct answer. Sorry, option A is the correct answer here because the sign is plus in the option C. Option A is the correct answer for this question. Now let's move to the next question. It is given that the jet transform of x of n is x of z. And what will is jet transform of z naught to the power of n x of n? So what will be the jet transform of this? We have to find. So let's suppose x dash of n is equal to z naught n x of n. So z transform of x dash of n will be summation. So using the definition of z transform, we can write like this. So this will become z by z naught to the power of minus n. We can write. Okay. So now this we can easily say. So this is x of z by z naught. Okay. That will be x of z by z naught. So option A is correct. Now we know that z transform of like in this question it is given a to the power of n u of n is equal to 1 by 1 minus a z inverse with ROC is mod of z is greater than a. So now find another sequence with the same z transform but with ROC equal to mod of z is less than a. So we have to find the another sequence. So to have the same z transform but the opposite ROC, let us rewrite the z transform in a different manner. 1 by 1 minus a z inverse, we can write this as 1 minus 1 minus a inverse into z. So here this will converge when like this will converge when a inverse z magnitude of this will be less than 1. Okay, which is equivalent to mod of z less than a. So now let's take the inverse z transform. 1 minus 1 by 1 minus a inverse z. So this will become, you can write as 1 minus a inverse z to the power of n, and n is equal to 0 to infinite. So it implies that this will become minus. So this we can write as minus n is equal to minus infinite to minus 1 a to the power of n, because we have done minus n change to n, and z to the power of minus n. So this will become again, we are taking only the unit step function for the negative value of n. So however, this is our like this is the function for which that is the z transform which is having the opposite ROC. So now ROC is mod of z is less than a. And what is the function? Minus a to the power of n u of minus 1 minus n. So option B is the correct answer for this question. So now coming to the next question, determine the inverse Z transform of the following function for all possible choices of ROC. So in this question, x of z is given as, and this is our x of z. Okay. So this we can write it as 1 plus z inverse. So in this way we can write, when you do the multiplication in denominator, you will get the same term. So now after cancelling it out, we will get, so xz has two poles and z is equal to 1 and z is equal to 6. And what will our x of n? X of n will be 6 to the power of n, u of n. And in this case, ROC is greater than 6. X of n can be minus 6 to the power of n, u of minus n minus 1. As we have seen previously, we can have opposite ROC also. So this is between 1 to 6. And also, xn can be minus 6 to the power of n, u of minus n minus 1, mod of z is less than 1. So all the option A, B, C are the correct answer for this question. Now consider an LTI system with input and output denoted by Xn and Hn. The impulse response of the system is Hn and Hn is given as 0.25 to the power of n u of n. What can be said about the causality and stability of the system? So Hn is given now. The Z response will be H of Z. Z transform will be. So this is H of n summation Z to the power of minus n, and value of n is equal to minus infinite to plus infinite. So this we can write as 0.25 to the power of n. It's a unit step function. So n will be from 0 to plus infinite now. And this unit step function will go z to the power of minus n. So we can write this as 0.25 z inverse to the power of n. So it implies that our h of z is equal to 1 by 1 minus 0.25 z inverse. And what will be ROC? This is less than 1. So the first point concluded is Z transform has one pole at Z is equal to 0.25, which ROC mod of Z is greater than 0.25, because here you will do 0.25 by Z greater than, so this will be mod of Z is greater than 0.25. Now ROC includes Z is equal to 1. So it implied that the system is stable. Okay, because ROC is greater than 0.25 and it also includes Z is equal to 1. So the system is stable. And Second, ROC includes Z is equal to infinite. So this means the system is casual, causal system. So here system is stable and causal. So today we will end the lecture here only. So before that we will see if any good question is there. We'll solve one or two more good problems. We will see now the final value theorem and initial value theorem, and then we will close the lecture here. And we'll solve one small example. So first we will see initial value theorem. So actually it states that x of 0 will be limit like if we have to find the value x of 0, so that is limit of z tends to infinite x of z. So we can also do the proof like x of z is given as summation x of n z to the power of minus n. So this can be written as x of 0 plus x of 1 plus x of 2. Now let's keep limit of x z tends to infinite. So this will become limit z tends to infinite x of 0 plus x of 1. So, so this will become only x of 0. So in all other terms, when you put 1 by z, z is infinite, so that will become 0. See, this is 1 by z. When z tends to infinite, this term tends to 0. Okay? So this is important. Now next come to the final value theorem. The final value theorem states that x, like the final value x infinite will be limit z tends to 1, 1 minus z inverse x of z. And whole of 1 minus z inverse x of z must lie inside the unit circle. This is also should satisfy. Whole of 1 minus z inverse x of z must lie inside the unit circle. So the two note point you remember, like for a ratio, like polynomial function having numerator and denominator, if order of numerator is greater than denominator polynomial function, then initial value theorem is not applicable. Now note 2, final value theorem is not applicable when the magnitude of pole is greater than unity. Is not applicable when the magnitude of pole is greater than unity. So this means pole must lie within unit circle. Okay. So now let's take an example. Find the initial value of the signal whose Z transform is x of z, that is given as 1 plus z inverse divided by 1 minus z inverse 1 plus 0.5 of z inverse. So first we'll check the condition, like the order of numerator is greater than it, not applicable, but here it is less. So it is applicable. So using initial value theorem, x of 0 is equal to limit z tends to infinite x of z. So this will become limit z tends to infinite 1 plus z inverse divided by 1 minus z inverse 1 plus 0.5 of z inverse. So this will become 1 plus 0, 1 minus 0 to 1 plus 0.5 into 0. This will become 1 by 1 into 1. The initial value of this will be 1. So today we will close the lecture here only. Thank you for attending. So we have recorded this video and also will upload on the YouTube, and link will be shared in the NPTEL portal. For any doubt, you can comment in the YouTube section also. Thank you.